Hello everyone, welcome to this video. In the previous videos, we have seen introduction to computer hardware and software, where computer generations, computer types, bits, bytes and words we have understood. In this video, let me tell you what is CPU, what is primary memory, what is secondary memory, what are ports and connections, and input-output devices in a computer, and how the computers are connected in a network. Let us see one by one. First one is CPU. What is CPU? CPU is Central Processing Unit, and CPU will be the heart of the computer, we are going to say. The CPU is very important component in the computer, and we say this is a heart of the computer. This CPU will be consisting of these components such as ALU, CU, special function or special purpose registers and a clock. ALU is Arithmetic and Logic Unit, means a computer is required to perform many operations, like if you give the input, it should process and give the output. To do that process, we will be having ALU. What process it is going to do? It will calculate the arithmetic operations. It will do the arithmetic operations and it will do the logical operations. Arithmetic operations means it will be doing addition, it do subtraction, it will do multiplication, like that. Logic operation means if you want to change 0 to 1, if you want to use AND gate, if you want to use, we need to shift the values like this, where logic unit is going to do. So ALU is a device within the CPU. It is going to perform arithmetic operations like addition, subtraction, and logical unit will be doing some logical operations between zeros and ones. That's why ALU is required to carry out these operations. And we will be having CU, control unit. You can observe here, we will be having CU with ALU. This control unit is required to control the flow of signals between the ALU and the storage. Means in the memory we will be having the data and the code, and to communicate with the ALU and the primary or secondary storage or memory, we require this control unit. And special purpose registers. Special purpose registers are there with ALU. The output of the ALU will be stored in this register, and also sometimes this register will be containing the value which ALU is required. That's why special purpose registers are there in CPU. And there is a clock signal. What is clock means? In any computer or any mobile phone, if you want to take, you will check the speed of the mobile, right? If you checking the speed of the mobile means the frequency of the processor, we are going to say. Frequency of the processor means how fast the processor is going to perform the operations, right? That is represented with frequency. So to decide the frequency, we require a clock signal. If the clock speed is more, if the frequency of the clock signal is more, we say the speed of the processor is more. So this is the clock signal. This plus minus kind of pulse signal will be called as a clock signal, and this clock is necessary to make the operations. Suppose we need to do addition, it is going to do addition here, and then if you want to do subtraction, it is going to do subtraction here. In one clock cycle, it will be performing one operation. So clock signal is required. The frequency of the clock signal decides the speed of the processor. So here we will be having registers ALU, CU, and also clock. With that, we will be having secondary and primary storage memories with the CPU. This is CPU, and we will be having memories with that, and also input and output devices we are going to connect to the CPU. So CPU contains ALU, registers and control unit, as well as a clock signal connected to it. You can observe here there is an explanation given. ALU is a super calculator. It will do these operations. And CU is controls the way data moved between the various components, ALU or CU, like that. CPU uses high speed registers to store the current instruction and the data. Whatever the process the ALU is going to do or CPU is going to do, that will be having the instruction, means we are going to write the program and those instructions will be coded, and that will be understood by the CPU. And also data means whatever the values we are going to give. Suppose if you want to add, we will be using plus sign, right? So instead of plus, if you use add add, this will be called as an instruction, and the value we are going to add 2 plus 3, this is data. Okay, this is an instruction, these two are data. So that is what CPU is going to do with special function registers or high speed registers, we can say. And one of the registers, program counter. Program counter is one of the very important register. What this program counter is going to do? It stores the address of the next instruction to be executed. Means we have written a code or program. It will be having 3, 4, 5, 6 lines. So the first line will be executed first, and then the second line, and then third line, then fourth line, then fifth line. This is how the execution will be, right? The CPU will be executed in this way. While executing the first instruction, the values of the first instruction is 2 plus 3, the values are taken and fetching and decoding and execution is going to do. By that time, program counter will be having the next instruction, the address of the second instruction, what the CPU is going to address. Okay, and the process will be called as fetch, decode and execute mechanism. And the instruction is first fetched from the memory. The instruction will be present in the memory. It will be fetched first, and then it will be decoded. If we decode only, the CPU will understand what is that instruction is. That's why it is decoded and understood the instruction, and then it will execute. And the CPU can execute only one instruction in one clock pulse. I told this is the clock pulse. I told the addition will be done in this time, and if you want to subtract, in the second cycle it is going to subtract. So this will be called as one clock pulse. In clock pulse it will execute one instruction, and faster the clock, faster the execution is. CPU today are rated in gigahertz. You can observe the processor in the CPU is 5th generation or i5 processor, i7 processor or i3 processor. You might have known, right? These processors are having high frequency in gigahertz. Next we will be having memory. In memory there are two types. One is primary memory, another one is secondary memory. Let us see what are these memories. Memory is the collection of chips. It will be having a collection of chips on the motherboard. It will be there on the motherboard where all computer processing and program instructions are stored. The computer processing and program instructions are stored in the memory, and here primary memory is the main memory which stores the data and programs. Okay, this is the main memory within the CPU. With the CPU there will be a memory called primary memory. It is the main memory, and the size is less than the secondary memory. You can observe here the size of this primary memory is less than the secondary memory. So primary memory will be having the size less than the secondary memory. Remember this. And it is costly also. Why it is? It is integrated with the processor itself. That's why it is costly. And the two types of primary memories are RAM and ROM. RAM, you know, that is random access memory, right? Random access memory is RAM. ROM means read only memory. Okay. Now let us understand what is RAM and ROM. First one is RAM, random access memory. This is volatile memory, means whenever the power is off, when the power goes off, the data what is stored in the RAM is going to be deleted. Remember, volatile means whenever the power is on, it will be holding the data. When power is off, the data is going to be vanished. That is RAM. And two types of RAM is SRAM, static RAM, and DRAM, dynamic RAM. You can observe the difference between the SRAM and dynamic RAM. SRAM stores the information as long as the power supply is on and reloads every 2 milliseconds. For every 2 milliseconds, we need to reload the data. Then only it will be storing continuously. And DRAM means it loses data in very short time. In very short time, the data will be loosed, or we can say deleted. Multiple transistors are used to store 1 bit. In SRAM, if you look at the circuit of SRAM, it requires many transistors. But here in dynamic RAM, only one transistor is enough to store the data. And this SRAM is expensive, faster and bigger. Here DRAM is inexpensive, slower and smaller. And SRAM requires more power. This DRAM requires less power. And it is not required to be refreshed. Here refreshing is required. That is the difference between SRAM and DRAM. And then ROM, read only memory. What is read only memory means? What happens here in ROM, we are going to store the instructions or the code data, or we say the permanent storage is required. Wherever the permanent storage is required, wherever the software is to be stored, we are going to use ROM. It is a permanent memory that can be read but not written. Means we can read what is stored in the ROM, but we can't write. Write means what? We are going to load this. We are going to yes, I can call load. We can't load this ROM again and again. We can read the data present in ROM. Read can be done. We can't load, or we can't write into the memory. That is ROM. Okay, we can't write, we can do read. It is non-volatile. Non-volatile means even if the power supply is not there, it will not go vanished. It will not get deleted. Right? There are two types of memories we have seen, RAM and ROM. Again in RAM we have seen SRAM and DRAM. Similarly in ROM we will be having PROM, EPROM and EEPROM. What is PROM means? It is programmable ROM. Okay, it is programmable means the data what we are going to store in ROM we can program and store. Right? It is programmable. What is EPROM means? Here again PROM means programmable ROM. What is E? Extra E here? It is erasable. Erasable means we can erase the data what we have written earlier. Then we will be having EEPROM. Double E here we will be having. EEPROM means electrically erasable programmable read-only memory. These are the three different types of ROMs available. And then the another type is memory called cache memory. This is cache memory. It holds those portion of the program that are frequently used by the CPU. What is cache memory means? How you can remember this means something like you will be having WhatsApp. Okay, WhatsApp in your phone. You are using this WhatsApp regularly. If you are using this WhatsApp regularly, this is not an unused application. Means what happens? In the CPU, there will be a cache memory. This cache memory will be holding the data of the WhatsApp, and once you are going to open the WhatsApp, whatever the data present in WhatsApp will be displaying suddenly. Means it will not take much time to display the data which is available in the WhatsApp. If there is no cache memory for the WhatsApp, what happens? If you open WhatsApp, it will take time, it will load, and then it will take time to display the data in WhatsApp. That is the difference between cache memory and other memories. Okay, cache memory is required where the program that frequently used by CPU, that will be cache, and it acts as a buffer between CPU and RAM. Okay, the CPU first look for the instruction in the cache, means it will look for the instruction whether it is there in cache. It executes faster than RAM. If that is what I told. If WhatsApp data is present in cache memory, it is easy to access for the CPU and it will display faster. If there is no cache available for the WhatsApp, if you have cleared the cache memory, what happens? It will take from the permanent memory and then it will be displaying. That's why it is getting slower. If it is there in cache, it is faster. And it is expensive, limited in size. In level 1, only 32 KB of cache memory is there. If it is level 2 type, it is 256 KB, and if it is level 3, only 8 MB. You can observe it is very less compared to RAM and ROM. RAM and ROM are very high memories compared to this cache. And registers. Registers means in CPU we will be having ultra fast registers integrated into CPU. That is fastest memory of the computer, where something like 8-bit data can be stored. Only 8-bit memory is this, or sometimes it is only 4-bit depending on the processor. Only 4-bit of data is stored. It is very less register. It will be called as register. And then secondary memory. The primary memories we have seen RAM and ROM. Secondary memories are hard disk in your computer. It is very big size, up to 512 MB or 1 TB or 2 TB. Likewise, we will be having huge data, or to store the huge data, we will be having extra memories, that is called as hard disk. And also magnetic type disk we can use, and also optical disk like CD-ROMs, DVD-ROM, Blu-ray disc. These are the different types of secondary memories. Nowadays we will be using hard disk and SSD also nowadays we are using. So these are the secondary memories. We can use a floppy disk, flash memory. These are the things we can call it as secondary to the computer. These are not directly connected with the CPU. Whenever it is required, CPU will be taking the data from the hard disk, right? That is what the secondary memory is. And you can make the difference between primary and secondary. The size of the primary memory is very small, the secondary memory is very large. So, and it stores the programs and data currently needed by the CPU, and it is used to store the large amount of data, right? You will put your large data in your hard disk of the computer. And this primary memory is very expensive. If you want to replace a RAM of very less memory, it will be very costly, right? For this amount you will be getting the hard disk itself, right? That's why it is inexpensive, this is expensive. And volatile in nature means this RAM is going to be, the data will be deleted once the power is off, but the hard disk data is not going to be deleted. That's why it is non-volatile. And then ports and connections. You might have observed these things in your computer. You will be having a USB port, right? USB port is there in your computer. It will be called as universal serial bus. Okay, here this replaces the serial and parallel ports in the motherboard. This USB, once the USB comes into existence, serial and parallel ports are there in motherboard earlier. This is replaced that, and most of the computers will be having USB, you guys know that. And the version of USB will be USB 3.0. if we take the different versions of USB. If we take USB 3.0, we can transfer 1 GB of file in just 20 seconds. Okay. The smaller variant micro USB port is also used in some smartphones. And then we will be having serial port. This serial port transfers 1 bit at a time serially. Serial port means if you have a port, this is a computer, we will be having a port here. It is connected to a serial port. Only 1 bit will be coming at a time. Means if you want to take data of 10 bits, one bit will be coming to the output. Means if you have 1 0 1 0 1 has to be transmitted out, this 1 will come first, and then 0, then 1, then 0, then 1. This is serial, one after the other. Parallel means at a time all these outputs will be available for us. Okay. They are offering 9 pin up to 25 pin configuration also, connecting, they were used to connect the keyboard and modems. These are the serial port. And then we will be having parallel port also. This uses data parallelly. Means I said at a time all the output is going to be available. Means if the parallel output is there, we can write like this. Okay. If the serial output is there, there is only one output. Okay. That is what the meaning. 8 bit in the sense 8 pins will be there. And this is implemented using 25 pins, and usually for printers. This parallel port will be used for printers. This serial port will be used for keyboard, mice, modem, like that. And we will be having VGA port also. You might have know this video graphics array port, where this is a 15 pin port, allows the transfer of audio as well as video to the monitor. To connect a monitor to a computer, you might have used this VGA cable, right? This replaced DVI, which uses data, digital data, that is used by flat LCD panels. Okay, nowadays we are going to use digital video interface, where it uses the digital data. And then we will be having RJ45 also. That is this is an Ethernet. To connect to internet, you will be using this RJ45 port, that is wired. Okay, and then PS2 port. This you might have seen in some computers where mouse and keyboard are connected with a purple and green ports. You can observe in CPU, if it is a older one, mouse and keyboard is connected, it will be having green color round port and a purple color port, which will be used for connecting the keyboard and mouse. Nowadays USB port for a keyboard and mouse connection is available. And then we have input and output devices. You guys know these things. Input devices for a computer are keyboard, pointing devices, and then sometimes a scanner also act as an input device. Means input device in the sense, if it is a computer, we are giving the information to the computer from the external world, from keystroke or from using the mouse, like that. These are the input devices. Output devices means a display, right? A monitor will be called as a output device, or there is a printer where we are going to take the printouts. This is a output device. And also plotters to plot a graph. Those are plotters, will be called as output devices. And then computer in a network. If the two more computers are there, how those computers are going to be connected is the next thing. You might have know, we are going to call it as a LAN, local area network. This local area network will be having connections between the computers, right? We'll be having two more computers and connect. What are all the methods of connecting the different computers is the thing we need to understand here. We can connect computers in a bus topology. Bus means there is a direct one connection. For this we are going to connect the computers like this. Okay, here is one computer, here is another computer. We are going to connect wherever it is required. A single line is coming in between all the computers. This will be called as bus topology. There is another method called hybrid topology. This will be called as a hybrid topology. And if the computers are connected in ring, one after the other, in a ring topology. And also similarly we will be having star topology. This is the main system where the 5 other subsystems are going to be connected. This is mesh topology, similarly a tree topology. These are the different ways of connecting the many computers in a network. Network means different computers or many computers connected together will be called as network. And then network types, as I said, LAN, local area network is there. Within the office we will be having some 5 systems we need to connect together. Whatever the data present in one system should be accessed with other system. In such case we are going to use LAN. This is local to us, local area network. And if some other systems can be connected where building to building connection has to be established. There is an apartment where there are many homes, or in a work location we will be having 2 more buildings, we need to connect the systems present over there. This will be called as metropolitan area network. Okay, building to building like that. Suppose similarly here also a building to building will be called as campus area network also. It is more than this campus area network, we will be calling it as metropolitan area network. And within the home we will be having some systems which are connected in wireless, wired phone is connected, that will be called as home area network. And all the systems in the outside world, it is connected to an internet, then it will be called as wide area network, where the network range is very high. And then network hardware, what are all the components this network will be consisting of? If there is a system, okay, it is connected to some other system through a internet or through some other bus topology, we can say, there will be a switch. You can observe in your system or in your internet provider, they might have given a switch or a port where the internet cable is connected, right? And from the to the tower or to the where he has made a connection for other system or other home, there will be a connection from this also. So where here there will be a switch, it is connecting two more systems, system number 1, system number 2, like that. From there we will be having a router. Okay, this there will be a huge network where wide area network link is coming to the router. This router is connecting to a switch to give the access to different systems. Minimum connection will be having in the switch, and then a router. Then we will be having connection to the switch through a file server also, and there is a hub where the two routers are going to be connected, or it will be also connected to a client. So these are the network hardware components like switch, okay, and then router, and then hub, okay, and also a client system, and also a server system. These are the components present in the networking hardware. And then some software basics you need to understand. What do you mean by a software? Software means it is a collection of code. Collection of code means line number 1, line number 2, line number 3, line number 4, line number 5 we have written. What we have written here, suppose we need to write a program for addition. Suppose addition is to be done, I am going to declare input A and input B. I am going to add A plus B. I need to store it to Y, and this Y will be taken to for the display. So this is what the program is, right? The system has to understand the two values are given, that will be coming from A and B, and I need to add, there is a plus instruction or something, sometimes we will be having add, add or subtract, minus. These are the things written in the code to perform some operation like addition. And this will be, the set of code and instructions will be called as software. This software is a collection of code that drives a computer to perform related group of tasks. This is a simple example I have given. Similarly, multiple tasks a CPU or processor is going to do, or a computer, that code will be called as a software, right? And that code or a software will be consisting of programs inside, right? This is a program. This program will be loaded into a computer, right, or a processor. So programs are there in software and uses a language. What language it is going to use? It may use C language, or it may use C++ language, it may use Java, it may use Python, it may use Perl. These are the different languages available, and where the program is going to be written, and it will be sometimes also called as the source code. Okay, the programmer will be doing the source code using these programming languages, and this software is going to be developed to operate multiple platforms also. And there are two types of softwares you can easily categorize. One is a system software, another one is application software. Okay, your mobile phone, if you take an example of a mobile phone, okay, this mobile phone will be having Android. This mobile phone will be having Android software. This Android software will be an system software. Okay, and this mobile phone also will be having WhatsApp. This WhatsApp will be having a software which is installed app that is called as application software. This is the only simple example you can understand between the system software and the application software. WhatsApp is an application, right? And the Android software what we have in our mobile phone is an system software to operate the mobile phone, right? Similarly, with respect to the CPU or the computer is concerned, we will be having Windows XP, or nowadays Windows 10 will be having. These are the OS. This will be called as system software, where we are going to use Chrome, or we are going to use Google, or we are going to use some Adobe application. These are having application software. Okay. Now you can understand system software is using an operating for operating a computer hardware, and application software is used by a user to perform some specific task. We are going to use this application software to give the input to the system, and system software will be having an operating system and it will operate with the computer hardware. This system software are installed on the computer while operating system is installed, but application software is installed according to the user requirement. If we require Adobe Photoshop, we are going to install, otherwise we will not. But operating system has to be installed to operate the computer, and in general user does not interact with this system software. We are not going to directly interact with the OS, just we are users. The user is going to use the application software and we are going to give the instructions. And system software can run independently. It provides the platform for running application softwares. There will be OS, and once the OS is there within the system, we can use the applications to install, right? So system software can work independently, can run independently. It provides the platform for running the application software inside. But application software cannot run independently without OS. They cannot run without the presence of the system software. OS should be there first. And some examples of the system software are compiler, assembler, debugger, driver. These are the examples of the system software. Directly I said it is an OS, but the system software installed on the computer when OS is installed. What do you mean by OS then? Operating system. These are the softwares will be called as OS, right? And then some examples of the application software as I said, Google Chrome, web browser, or word processor, some media player, VLC player. These are the things we call it as application software. I hope you guys have understood this, and in the next video we will be seeing how the computer C programming will be written for a simple program, and the different components are going to be studied. Thank you.